Alright, let's go through section 3.4. Notice that today we're going to solve equations with variables on both sides of the equation. Both sides of the equation. So we're going to look first at these three vocabulary words: one solution, identity, and no solutions. When we use this phrase, one solutions, we're going to be talking about having a single answer, an answer, or a value for our variable. So x equal to 4, y equal to -10. This is called having one solution. What we're going to see in today's lesson is that sometimes any number that we want will cause my problem to work, or no matter what number I choose, nothing's going to work. In a problem where we have an identity or infinitely many solutions, no matter what, we'll get a true statement. Because when we solve and we get to the bottom of the problem, we're going to have something like 4 equal to 4, or -130 equals -130. We might even get to a point in the problem where we have something like 2x equals 2x. It's kind of a spot where you go, duh, it's going to work. In contrast, we'll have a no solutions, or nothing will work no matter what we plug in. If we end up in the bottom of our problem and we have something like -6 is equal to 2, it can't happen. Or maybe we'll get something like x plus 5 is equal to x minus 1. Well, there's no way that I could take a number and add 5 to it, and take that same number and subtract 1 and expect to get the same value. We always go back to think about money, right? If you're supposed to get paid a certain amount for a job, and they're going to increase your pay by $5, can never be the same as if you're going to get paid a certain amount for a job and they're going to take away $1. So just be cautious. This impossibility, things that can't happen, are going to cause no solutions. And we're going to write that down with this 0 with a slash through it. It's called the empty set. Oops, I guess I didn't line that up very well. But that's the empty set. It's a 0 with a line straight through it. The identity, or all solutions, sometimes we write that as infinitely many. Use that infinity sign. Alright, so now what are the new solving pieces? The new solving piece, so that's what can happen in our problem. The new solving pieces are just a little bit different in that now we're going to look at our problem and we're going to see that that balance line has a variable on the left and on the right. That's how it's different. Variables on both sides of the equation. How can we begin to solve this situation? Well, when we begin, we have to collect our variables on one side of the equation and the constant terms on the other to solve equations with variables on both sides. So we're going to collect the variables, and usually we collect the variables on the left, but it doesn't have to be. The rule of thumb is move the one that is smaller. Remember that this also means that when we say smaller, it also means more negative. So the one that's smaller or the one that's more negative. So in this problem, our first step is that notice step. And when we notice in this problem, 4a and 9a are like terms, and they are variable terms on different sides of the balance line. So the first thing we need to do is move this 4a to be with or combine with this 9a. So we're going to go ahead, and because it needs to cross the balance line, we have to use inverse operations. So we'll subtract 4a, because then we would have 15 plus 0. So on the left, we now have 15 is equal to 9a and -4a make 5, 5a. And we didn't do anything with that minus 5, so it hasn't disappeared, so we'll subtract 5. Once we've collected our variable terms, now we're back to a two-step equation. So that we add 5 to both sides. So that 20 is equal to 5a. We divide both sides by 5. We end up with 20 over 5 is a 4. My equal to stays on my balance. And 5 over 5 becomes a 1. So we have our 1a. A is equal to 4. And then we could go through and check our answer, right? 15 plus 4 times a is equal to 9 times 4 minus 5. So 15 plus 16, that is 31. And 9 times 4 is 36 minus 5. That is also 31. So yep, this equation has one solution. One number worked. A equal to 4. That's our solution. Let's work through number 2. Notice here that we have another case where your variables are on two sides of the equation, but this first side, t plus 3 times 6, needs a distribution step before we can even think about combining like terms. Because there's more than one t, we can't use our shortcuts. We have to distribute because we have to group those t's together. So on the left, there's nothing we can do. Just has to tag along. And on the right, we have to do a distribution. So that's really just multiply. 6 times t gives me 6t. And 6 times positive 3 gives me positive 18. Now we're to the same kind of problem we had before. Our t's are on opposite sides of the balance line, so we need to use opposites to combine them. Subtract 4t from both sides, so we get 0. Be careful, 0 minus 12 is a negative 12. 6t plus negative 4t is 2t. And that 18 just tags along. And now we're back to that two-step equation. We need to subtract 18 from both sides, because that would give me a 0 here. Subtract 18, that's going to give me negative 30 is equal to 2t. Divide both sides by 2. So that negative 15 is equal to t. We take that negative 15 and we plug it in. Negative 4 times negative 15, then subtract 12, is equal to 6 times negative 15 plus 3. So on the left, that's negative 60 minus 12, so negative 72 on the left. On the right, 6 times, that's negative 12, which is, yep, negative 72. So once again, we found that we have one solution.